This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. So, welcome to the Math Map Book Club, where Kirsty Gilpin and I spend time each week discussing the Math Map, the curriculum used by Classical Conversations communities to help our children to know God and to make Him known through numeracy. And we're on our summer series, which is almost over. And Kirsty, you've had a great job with your team teaching us all kinds of games. So, let's start playing. You know what I think I forgot to say while you're unmuting? It is July 16th, 2025.
All right, I'm sorry, I didn't realize I was on mute and I got the slides shared. So we are talking about race to the origin and checkers today. And just a reminder, we've been doing 2 booklets per week over the summer, and we've had our mentor tutors, Jill Philbrick and Babs Harrell, that have been helping us play these games and work through what this looks like at home with multiple different ages of students. We've been looking at our published instructions, and we've also explored a lot of adaptations. And of course, every week we want to give you the opportunity to ask your questions so that we can answer them. So I just want to point out before I turn this over to Jill that there are 2 games this week. One that is unique to the Math Map and very inherently mathematical, and one that is much more familiar to all of us. It's a classic game. And it would have been so easy for Jill to say, hey, let's swap games this week so that I can do the familiar one and you can do the one that is more unfamiliar to me. But she didn't. She has wrestled all week with this game so that she can share it with you. And I just want to point out the fact that our mentor leaders, our mentor tutors, and our helpers like Shauna, they're wrestling with these ideas themselves so that when they share their expertise and their experience with you, they're really coming at this from not a place of being a math expert, but coming from a place of being, hey, I am your average mom. Although Jill and Babs would both claim that they were below average when they started with the Math Map when it came to math. But they really represent people who are just your average moms. They didn't come in with any special training, but they have been working through the Math Map for years, and they have grown so much, and they are wrestling with hard ideas and really, really leading from the front. And so when you hear them, I really want you to be encouraged that they didn't come into this special, but they were special. Let me be clear, right? They're special, where everybody's special, but they didn't have any special math training before they came into this. But they really are on the vanguard of what happens when you do several years of work in the Math Map. So, Jill, I just wanted to give you.
Well, I want to add to that because they did come in with something that any mom can come into, and I know they'll nod. They've been practicing the classical model for a number of years, which therefore makes it so they can learn anything.
Absolutely. So with that said, I am going to go ahead and uh, turn this over to Jill, and she is going to walk us through our first game, Race to the Origin.
So we can start our session with reciprocal compliments and just say that I think it is amazing that Cece and that Lee and Kirsty and all the different leaders that we've had, they don't say, okay, you don't do this one. They just we just rotate 1, 2, 3, 1, 2, 3, 1, 2, 3. And they don't say, actually, I think I should lead this one. And that says a lot. It's kind of like how God trusts us with creation. He doesn't say you're probably going to mess this up, so I'm actually not going to let you have it. But instead, they do trust us to learn and to ask questions, which is also, if anybody is listening to the the recordings of these later, really, they are available. I had questions, and so the help desk is there, emailing the math map, and they help, they care and want us to get it, and they do make themselves available to us. So if it's an unfamiliar game, then there's help. There's help. You don't have to just say, this looks beyond me and I don't feel like reading it, and so no. So on to the game. So this is the booklet for 27, which is complex numbers. And so you'll see that on the game board back here, we have the real axis going horizontally and the imaginary axis going vertically. And that's what they're familiar with from all the copying and all the work they've been doing all year. So pointing that out, students should be like, oh yes, okay, I've seen this before. This isn't the first time. So each player is going to roll 2 dice, and I picked a red for real, and then the white is the other. If you have 2 separate dice, different colors, it allows the students not to have to figure out which number they want for what. You're welcome to use 2 of the same color dice. One is going to be your real number, and the other is going to be your imaginary. This is all one number, but the real part of the number and the imaginary part of the number. But if you can have 2 of the same color, but if it helps your students not to have to think too hard about it, just use 2 different color dice. So that's going to give them their first quadrant position. So both those numbers are going to be positive, and you'll place a marker wherever it would be. So if it's 2 plus 3i, then you would go over to the 2 and up to the 3i, and you would put your game piece or little piece of painter's tape, whatever you want to do to mark that spot. And after that, you only need 1 die because you're going to rotate based on your roll. If you get a 1, you're going to rotate 90 degrees. A 2 is 180. A 3 is 270. A 4 is all the way around to 360. If you roll a 5, you lose a turn. And if you roll a 6, everybody has to go back a space, which we can talk about what that looks like. So some things that I had to learn to be able to do this game was how to say z prime, z double prime, and to know what that means. It's the new position. It's change in z. So z is where you start with your first roll. Z prime is your change to the first new position. Z double prime is the change to the next position. Z triple prime. So this could be a fun vocabulary thing with all the how many double, triple, quadruple, quintuple, or you could say the 7th prime of Z. If after a while it just gets a little too complicated and you don't want to have to say 11th tuple or however that might look. So just having fun with even the vocabulary could be a way to sort of diffuse any thoughts they might have. Also, we did do that transitions book, which was week 18, so they are a little familiar with some rotations here. Okay, so we can move on to the next slide, and some things that I had to review and that might be good for parents to review with their families are that complex numbers have 2 parts, the real part and the imaginary part, and that's written as a plus bi. A is the real part, b is the coefficient to the imaginary part. So if you're actually that shouldn't say z prime, it should just say z. But if your z, your starting point was 0 plus 2i, that blue dot on the board shows what that starting position would look like. And then they could look at when it's this way, when it's nice on the axis, they can picture that rotation. And that can be a place for them to begin to see the pattern. So we see that to go from the 0 plus 2i over 90 degrees counterclockwise makes us have a -2 plus 0i. So one thing we can point out is what changed here. Where did that 2 go? It moved to the real portion and it became negative, and we see that it goes back and forth, kind of makes this zigzag as we go around because we're getting onto the new axis. So we can study and review what this rotation looks like if we begin on the imaginary axis, looking to see what signs change. And as we're looking at the quadrants, now when they're on an axis, they're really not in a quadrant. But in our next slide, we can see what happens if we begin on the real axis. So the same thing, the blue is our beginning point, and then the yellow, I didn't change game pieces, it's just to show where we started. So again, that shouldn't say z prime, it should just say z. That's our starting point, 3 plus 0i. And if we rotated that 90 degrees, we can see what things change and what things stay the same as we go all the way around. So our next slide shows what would happen if we're actually out in the quadrants. Now it's a double, it's 4 and 4, so it doesn't, and I did this wrong too. Oh my goodness, it was late. Sorry about that. There should be some negatives there, but if you don't look at the typed part, if you look at the actual game board, you should see the right things. 4 plus 4i, they're both positive. If you move into quadrant 2, we have a negative 4 plus 4i. If you go into quadrant 3, we have a negative 4 minus 4i. And if you move into quadrant 4, that should be the positive 4 real and the negative 4i. So if we go to the next slide, we can begin the game. On this slide, we started with z equals 2 plus 3i. And so the blue dot shows that. Now, in the charts, there is, I think it's chart 27.2. It is. Chart 27.2 is a great place to note, if you're going to play this game, that it does show the rotations. It gives you some information. And so we can rotate, learning the pattern that we saw about what flips, what becomes positive, what becomes negative, and we can rotate that around. I really apologize. I was evidently more further on vacation than I thought I was when I made these. The blue should have rotated around. So, oh, that's after the next turn. We would have gone from the blue to the yellow to the next yellow, the next yellow. And then as you rotate all the way around and come in, you would move one, subtract one from your real and one from your imaginary. So the next square is correct. It would show where our next rotation would begin. And from there, if we made it all the way around, we would see where our next rotation would begin. So we're just we subtract one from anything we can subtract one from. If it's at 0 plus 1i, our next turn would land us on the origin and we would win. And you can look at this z double prime. If someone rolled a 6, everybody would have to move back out. You'd have to add one to your real and one to your imaginary, which would push us back into the one before that. Okay, so are there any questions before I go on any further?
So I
Jill,
just
I
want
had a,
to, okay, Shauna or
oh
Kristen.
no, it was, I just, so you were moving in, but we're not rolling the dice to see how we move?
Yes,
Or,
I'm sorry. Yes, you would need to roll the dice. If you roll a 1, you would go 90 degrees. If you roll a 2, you would go a whole one, a half, a 180. If you roll a
so,
3, you would go 270 degrees. So those yellow dots, that would only be 90 degrees at a time. If you
okay,
rolled a 2, you could skip that first yellow dot and go all the way to the second yellow dot.
okay, so the upper uh, graph, if I rolled a 2, then going 180, I would be in quadrant 3, my blue dot would be
Yes.
in quadrant 3. All right,
Yes.
but if I rolled
Exactly.
a 3, I would be in quadrant 4, kind
Right.
of down below, and I wouldn't have to
Yes.
move 90, 90, 90, 90, 90.
Correct. Thank you for asking that.
Okay. Okay.
That is exactly right. And so if you, I think in the next slide, I have some dice there too that show a little about what that would look like. So on this next slide,
Well, before
if
you
we
go, let me
started,
add, in case I'm gonna check our actual final copy, but that 0, 0 origin should be 0 plus 0i to be most accurate.
oh,
So just so anybody watching this knows, we'll correct that if we haven't already.
that's a good point too. So on this first one, we have the 2 plus 3i, and those are the positions that they would be all the way around. But if on this roll you see they rolled a 2. So the black dot represents just where they would tap their game piece, but they would wind up where this yellow and the black is. So that would be the 180. If, however, after that they roll a 3, then they would move from that second game board over to the third, and they would have a tap and a tap, and that would be 1, 2, and the third one would move them in to their next position so that they would start their next rotation in. If they would, does that make sense?
So the next rotation in is where we minus out. So it was 2 plus 3i. So now I'm at 1 plus 2i because I've subtracted 1 to move myself in,
Right.
going more and more toward the origin as I make my
Yes.
circle. Okay.
Yes. Does that make more sense? Okay. So one more thing, I think the next slide shows some things I had to learn. And what was really great for me with this game was I have really enjoyed seeing those rotations of I to the I squared, I cubed, and seeing what happens with that I, that -1, the 1, the negative I, seeing how that changes. And I never had committed it to memory. And I think this game would help me do that. So I think, is there another slide that has the, so right here is the, so I, -1, negative I, 1 is that pattern. And it's going to just keep rotating around as our exponents increase with anything that we're doing to I. So that is found on the chart 27.2, and I think on every booklet it's going to be on lesson page 1, that you're going to get to see how they work through that multiplication of I, or I times I times I times I. And so having that handy and reviewing that first is going to really help. Because even though I showed you in the game how some common sense can help us see where that rotation is, there's also just straight math, and that's multiplying it. So whatever point we start with, like 2 plus 3i, we can multiply it by whatever we're trying to do on that rotation. If we were multiplying it by I to get to 90 degrees, here I showed you, I had to figure out this math too. You would think that the distribution is something I've done lots of times, but something about multiplying it all by I had to sit with it a little bit. I had to think about it a little bit. And I was not even at my computer. We were driving down the road, and all of a sudden, it's like your brain stays on search when you're trying to figure something out. And I was like, wait, I think I understand. Because what happened to me is as we did this 90 degrees, if you go down, we have 2 plus 3i. We're going to multiply that whole thing times I. Now we have 2 times I, and we have 3i times I, which gives us 2i plus 3ii. Well, I squared is -1. So we have 2i plus 3 times -1, and that brings us down to 2i plus -3. I do not know what it was in my head, but probably some other people can relate that at that point I was thinking, I can't graph that. I needed to remember that it's just still 2 parts. It's just still a real and an imaginary, and I can put them back in the order that is familiar to me. And I can make that -3 plus 2i. But I think those are the things that our kids sometimes they don't see it. And for us to very patiently, I mean, I'm sure that as a parent, my children would say there were lots of times that I just said the same thing louder and they didn't gain any understanding. But right? But if we can work through some of it ourselves and just say, let's look at it, let's talk through this. And if they say, but I can't graph that, instead of just saying, yes, you can, yes, you can, say, well, what are the parts? The classical model, just what are the parts and where do they fit? And we can find a 2i and we can find a -3, and it's the same thing. Really, I learned so much this one week going through this game. So I am grateful that that I grew. More wrinkles in my brain and fewer on my face is what I like to say.
I love that saying. Yeah, and then I want to add to that. So thank you for that testimony, because sometimes in the lower grades in the math, we do some things that seem ridiculous because no mathematician would ever do it because a mathematician knows what they're doing. But in doing things that are silly, you get this idea that it doesn't matter what's in that box. I can move it around, or I can multiply it, or I can come up with ideas that maybe are not mathematically how anybody would represent something. But just to try to break that paradigm that you have to have the right answer, which is good. Mathematicians want the right answer, but we also want to practice what the process is. And that's going to be hard for parents sometimes to distinguish between. And then the other thing I wanted to mention is even if you can't do any of this, if you just can't do what Jill just said she did, the one thing possibly you might get out of this game and this lesson set is a lot of -1 practices. Maybe even forget the I in the square root and just practice doing -1 times -1 times -1 times -1 and going back and forth between the negatives and positives. Because what you discovered is this rotation goes back and forth, not between negative and positive, but between real and imaginary. So if you can do it between negative and positive, why can't you go back and forth between real and imaginary? Why can't you go back and forth between red and blue? Why can't you go back between up and down? Right? We do this all the time, but these little digits sometimes just make our brain hurt and make us forget everything else we've ever practiced.
Another thing that I did as I was figuring this out is I actually, and you probably can't see it here, but I created a sheet and I just made I was like, okay, the twos, the two plus the imaginaries, three plus the imaginaries, and I worked it across and even just double checked it with Google to see, do I have the right numbers? And I began to discover what changes each time. And for our young kids, we can do some Nathaniel Bowditch or Bowditch for them, create the chart, let them find it, let them say it, and make it accessible. Just making it accessible is huge. We do have a couple ideas on the last slide with ways to change it up a little. One thing you could do is begin with only one die so that instead of having rolling for your real and your imaginary, you're just rolling for a real number or an imaginary number, and you just practice that rotation right there on the axes and not out in the quadrants. You can experiment with the doubles because that's also something they can see pretty clearly. And every time they come in, they can find where they're moving in. If you're following the full rules, you can use two colors of dice so that one is real and the other is imaginary. You can copy the game onto a transparency, and you could even rotate, kind of turn the transparency around and find some of your rotations that way. Using a safety compass and a protractor as manipulatives to find your 90 degrees to see where that radius isn't changing. Tracing circles on a page protector. Creating a chart like I showed you here so that you can refer to that and maybe check your math, having fun with vocabulary, playing in teams, and then using some fun game pieces. So those are just some extra ideas to go along with the game. If anybody thought of anything throughout this, questions or gaps or some ideas that sparked, then we'd love to hear from you.
I just think for with older students, it's, just practicing with I, the square root of -1 and that whole process, because I'm thinking about my challenge 4 students and and practicing that way, but then just seeing that we can do this fun game and then see the patterns that it develop. To me, it seems like there's more and more patterns in this than anything. We can see patterns everywhere.
That is so true. And then it even goes back to the patterns in rotations without the imaginary, just the a normal coordinate axis, how the switch that happens, the y becomes the x becomes negative, and all those different things. So if we spend, depending on what year they're in, they might have seen that in the transformations book and say, oh, I totally get this pattern here in the complex booklet.
I really appreciated that you connected the geometric idea of that rotation with the arithmetic multiplying by I to really help us see that this integration of mathematical ideas, right? So often we see them taught separately, and you really integrated them. So that was lovely. Thank you. All right. Well, that's a hard act for me to follow. But I had a very familiar game to lead us through this week, which was checkers. And I'm not going to talk in too much detail about how we play checkers because I think most of us are familiar. Um, the key idea of checkers is that you're only playing on the colored squares. So in this case, you were playing on the red squares. Everybody puts their pieces on, and then your goal is to jump over diagonally. So we're always going to be moving diagonally, and your goal is to jump over other pieces in order to capture them and eventually be the only one left with any pieces. So one thing that I thought of as a way to add a math element to your checkers game is that you could use vectors to describe your planned move. So for example, probably need to change my ink color here. So for example, if I have a checkers piece here and I'm going to move it to the right one and up one, I could say I'm moving vector 1, 1. And then I know that I'm moving in this direction. Or I'm moving vector -1, 1, right? Would have moved me in this direction. If I was going to be making multiple moves, right? So let's say that I ended up next to an opponent's piece, I might say I'm going to move vector 2, 2, and then vector -2, 2, right? So there's fairly simple vectors, but it's a way that we could still practice vectors by saying, this is how I'm going to move, and then actually moving that. We could use coordinates to describe where we're going to land. So if we wanted to, we could set up our coordinates in any way, but let's say we just chose to use quadrant 1. So this is the point 0, 0. From here, right? If I was going to land here, I could say I'm going to land at vector at point 1, 2, 3, 4, 5, 6, 7. I'm going to land at 7, 5, right? And so I can announce where I'm going to land to give me that practice of using coordinates. And then just thinking about Jana's question a couple of weeks ago about probability, you could add an element of randomness. And let me just erase my ink here. So in this case, right, perhaps I have a piece, my starting point is here, right? And maybe I flip a coin or I roll a dice or I draw cards to decide, am I going to move to this or this, right? And then, right, once I get there, which way am I going to do, right? So now there's this element of not necessary strategy, but randomness. And so we could talk about, right, what is the possibilities, right? Looking at our probabilities each time, right? I have a half of a chance of moving here or here, and then another half of a chance, right? So what are the probabilities that I land on any particular square? And it could become a fairly intricate examination of probabilities when you think about two people having turns, right? What are the chances that we're going to meet and jump one another? So you could even do that with fewer pieces. Maybe you just start with 4 pieces on either side of the board, and then look at the probabilities that you end up in any one place. So those were some ways that you could take what seems to be maybe a non-mathematical checkers game and add some elements of math practice to that. Um, but it's also just a fun game to play and think about ordered playing, right? So I have to be thinking about taking turns, moving my uh, pieces in order, following rules. Those are all things that are sort of inherently activate our math and logic pieces of our brain. And so it may seem like we're playing a game and not practicing anything overtly, but we're still practicing those skills that make a good mathematician. Because we know if you play checkers over a long period of time, you start to notice patterns, right? And we've talked about how pattern finding is really that hallmark skill of a mathematician. So does anybody have anything they'd like to share about checkers?
I have a question. So, do any of you know, like when they give the name of the locations on a chessboard? I know it's not checkers. Is it just literally a pattern and that those names always stay the same? Or is there some sort of vectors that you're paying attention to and get named differently than coordinates with chess? Because I hear people say, move my K8 to 752. Like, I don't even know. No,
I don't know enough about chess to
no,
answer that
okay.
question.
Nobody is okay. It's probably one of these examples where the game's familiar enough, and then just find, so we don't have a lot of questions because we know how to play, and we've been joining each other for so much now this summer that we can see what you mean by the coordinates to describe where you land, and that it really vectors describe all motion. So.
Right. Well, that brings us to our weekly reminder of how we can support you at home. I just want to really encourage everybody to share, right, with your communities, share with your friends. If you're watching the book club today, share with your friends um, that we have an incredible amount of support available to you. And I know I've said it before, but there's such a generosity of support that CC is providing. Unlike any other curriculum out there, not just limited to math, right? But I don't know of any other homeschool curriculum or public school curriculum that says, hey, you can email us for help and we'll get back to you. I know Babs and Shauna respond to most emails within the same day. Right. So we're not promising that, but they are really fast at responding to your questions. And they answer questions about the curriculum, how to use the curriculum. They answer questions about the classical method. What does this look like in community? What does this look like at home? We've had questions about testing or working with multiple ages at once, right? And we get questions about the math, right? So people that are like, help me understand this answer or help me understand this concept. So that is available to you freely. And um, And that's, I just think, remarkable, right? If you are a tutor, you can join a live help desk every single day of the week with them. You can get on a live help desk with me and get as in depth as you want to about the math. And all of that is provided for you as a benefit of being enrolled in a CC community. Um, and every single parent, right? Everybody can jump on our book club, right? Every single week, we have a time where we open up our book club for your questions. So whether they're pertinent to that week's topic or not, we're happy to entertain your questions. And I don't think that there is anywhere else that you have access to a curriculum's authors, right? To Lee Wharton's herself to ask your questions. And so if you're watching this, I just want to encourage you to please share that with people because we want to make sure that people know that the level of support that's open to them um, that they can take advantage of at no additional cost beyond their membership in community. So we also have the forums and your tutors. There's so much support out there. So help one another. I love the fact that CC talks about how homeschooling is better with a friend, right? And so you have a whole community of math friends to help you. So next week, we will finish up our summer series on games and activities. We'll be talking about lessons 29 and 30. In lesson 29, what does that look like to help your students design their own games? I think they're better at that than we think, but that'll be a fun conversation next week. And then at the end of July, we will jump into talking about what does this look like with multiple domains at home? And that does bring us to our Q&A time. So does anybody have any questions that they'd like to talk to today?
I have a quick question about just sharing with my community for the fall. Um, are you going to be using the same domains each time, or are you going to be moving, like shuffling around, or how is that going to work so that I can
I
explain that
think
better?
Sure. I think probably we've talked about using every week looking at integers, fractions, and monomials so that you get a little bit of a flavor of sort of our foundations level, our essentials level, our challenge level, and what might that look like if I have all of my children sitting together in front of me at the table. How might I do that? And I think we're going to try to sort of mix it up, right? Because we might have some families that do well starting together with a conversation and then letting the little ones go and trace independently while mom works with the older students. Some families may be flipped. They may have their older student who wants to work independently, and then mom's keeping the younger students on task. And we might have some families where they want to work together so that they're collaborating across those domains, and the older students are learning from the younger students' domains or helping the younger students through theirs. So I think we're going to try to sort of capture a little bit of each of those. So some weeks you might see us saying, hey, let's pretend we're working this way. And other weeks we may work the other way, to really try and encourage families that there's no one right way to work through the math map at home, but to give them some strategies that may be helpful.
Great, thank you.
Thanks everybody for joining us. Enjoy the rest of your afternoon. We have a nice sunny afternoon here in West End, so um, we'll enjoy that. We've had a lot of storms lately, so we'll enjoy a nice bright day here. We'll see you all next week.